Today's lesson is 1.1.2, Interpreting Complicated Expressions. And our objective is that students will be able to interpret expressions in terms of a context. So, algebraic expressions can be used to describe a lot of different situations. And an algebraic expression always contains a variable, and that variable can represent anything. It's important that we understand what each term in an expression represents and how each term interacts with one another. And having an understanding of that will help us kind of build our logic and be better mathematicians. So in order to do that today, we are going to be going through a couple word problems. The first word problem is already written down, and you should be copying this down in your notebook as well. It says, a new car loses an average value of about $1,800 per year for each of the first 6 years of ownership. When Naya bought a new car, she paid $25,000. The expression 25,000 minus 1,800y represents the current value of the car after y number of years since Naya bought it. What effect, if any, does the change in the number of years since Naya bought the car have on the original price of the car? So, pause the video if you need to, take a minute and copy this down. So I'm going to give you a couple steps that will help you go through the thought process to figure out whether or not the amount of years is going to affect the price of the car, the original price of the car. So first step is going to be to identify what each term represents. I need to take my expression, and before I can start figuring out what the expression means as a whole, I need to understand what each part of the term represents individually. So I'm going to go back to my problem and I'm going to read through it again. That's the best way for me to understand what's going on, to read through it a couple times. And this time when I read through it, I'm going to be marking a few different things. A new car loses an average value of about $1,800 per year for each of the first 6 years of ownership. So in that sentence right there, I had some information. I found out that the car loses money, and loses is a subtraction word, so I know there will be subtraction. And it loses about $1,800 per year for the first 6 years of ownership. Okay, let's continue on. When Naya bought a new car, she paid $25,000. So that is the second piece of information that I have. She paid $25,000. That was the original price of the car. The expression 25,000 minus 1,800 y represents the current value of the car after y number of years. So I'm going to underline this expression, and I'm also going to underline that y represents the number of years. I feel like that's going to be important for me to know what the variable is. Finally, let's underline the question. What effect, if any, does the change in the number of the years since Naya bought the car have on the original price of the car? Sometimes I think we forget what a question is asking us in math. So once we figure out one thing, we think, okay, I've got this. But we have to really be paying attention to what the question is. So my first step was to identify what each term represents. After reading through this, I feel like I have a pretty good idea of what each term represents. So let's write down the expression that we're trying to understand. 25,000 minus 1,800y. So the first thing I have in there is 25,000, and when I read it back here, I saw that 25,000 was how much she paid originally. So I'm going to label that 25,000 as the price of the car. Now 1,800, or negative 1,800, was how much we lost in value. So we'll call it loss of value. And because I have that y, I'm going to remind myself that it's the loss of value per year. So step 1 was to identify what each term represents. I've gone through and I've done that. Step 2 is to manipulate the identified term. Now, what I mean by manipulate the identified term is to look at the term that the question's asking me about, kind of mess around with it and see what effect it has on the other terms. So let's go back and look at our question one more time. The question was, what effect, if any, does the change in the number of years since Naya bought the car have on the original price of the car? So I need to look at the change in the number of years. Well, I know from up here that y represents the number of years. So it's asking me, when you change y, what effect does that have on the original price of the car? So let's go back. I'm going to manipulate this by changing the number of years, or substituting different numbers into y. So let's just bring down this term only, because that's the term that contains y. So I have negative 1,800 times 1. Let's actually scoot that over a little bit. So when I multiply that by 1, it's negative 1,800. Let's try multiplying it by 2 now, which will give me negative 3,600. And if we multiply it by 3, that will give me negative 5,400. So we are looking at this changing y value. First y was 1, then it was 2, then it was 3. And I'm asking myself, as y changes, does that change the original price of the car? Well, as y changes, it changes the loss. When y is 1, the loss is 1,800. When y is 2, the loss is 3,600. And when y is 3, the loss is negative 5,400. But it never changes the original price of the car. It will change the total price, but it's not changing the original price. And the reason why it doesn't change the original price is that this original price is a constant. It's one of those numbers that does not change no matter what is going on in the problem. So let's answer this question of whether or not a changing y value is going to change the original cost of the car. So I'm going to write, as y increases, the loss in value increases. That's what I just mentioned right here. As my y value was increasing, my loss in value was increasing. So as y increases, the loss in value increases, but it does not influence the original price of the new car. So let's just check and make sure I answered my question. The question was, what effect, if any, does the change in the number of years since Naya bought the car have on the original price of the car? And I said that as y increases, as we change the number of years, the loss of value increases, but it does not influence the original price of the new car. So I have answered my question. Go ahead and go back and rewatch this if you need to. We will do another example at the beginning of class so we can kind of talk about it in person. And don't forget to take your quiz at the end of this lesson.